Alright, welcome everyone. This is where we start the project. We're gonna build our own neural network in C++, and this video is the first step. Before we can move on to building the structure for our layers, we need to set up the activation functions that our network will use, ReLU and Sigmoid. We'll also create an enum to switch between them easily. These functions are essential for introducing nonlinearity in our network, and they help it to learn complex patterns. Okay, let's get started. We start with a header guard. This prevents the file being included multiple times and avoids duplicate symbol errors in the compiler. So here we say #fndef layer underscore HPP. fndef checks if layer underscore HPP is not defined yet. If it's not, we define it like this: #define layer underscore HPP. And at the end of the file, we close the header guard with #endif to finish the block. Now, let's include the necessary libraries. And here's the first one: #include vector to handle dynamic arrays. And we include functional so we can use function objects for activations. And #include cmath for mathematical operations. And the last one, #include stdexcept for handling exceptions. Here at the top, we create a type alias called activation function. And here we say, using activation function equals std : function double inside parentheses double. This represents a function object, something that you can call like a function that takes a double and returns a double. We'll use this for both activation functions and their derivatives. You'll see how we use it. Next, we define a namespace called activation to group all our activation functions. And here we say namespace activation. And inside the namespace, here's the ReLU activation function. Inline double ReLU, and it takes double x, and it will return inside parentheses x greater than 0.0 and question mark x : 0.0. It's simple. If x is greater than 0, return x, otherwise return 0. ReLU is great for introducing nonlinearity in neural networks, and we'll use it in our hidden layers. We mark this function as inline so the compiler can insert its code directly wherever it's used instead of making a separate function call. And here's the derivative of ReLU: inline double ReLU derivative, and it takes double x, and it will return inside parentheses x greater than 0.0 question mark 1.0 : 0.0. It's 1 when x is positive and 0 otherwise. We'll need this for backpropagation later on. Then we have the Sigmoid activation function: inline double Sigmoid, and it takes double x, and it will return 1.0 divided by 1.0 plus stdexpov -x. Since our project is a binary classification problem, we'll use this function in the output layer. The reason we often use Sigmoid in the output layer is that the Sigmoid function maps any values between 0 and 1, making it great for probability-based outputs. Next, we define the derivative of the sigmoid function. inline double sigmoid derivative and it takes double x, and inside the function we have double s equals sigmoid of x, and we return s times inside parentheses 1.0 minus s. This is the sigmoid derivative, and we'll also need this for backpropagation later on. That's it for the activation functions. Next, we define an enum class called activation type. This allows us to select the activation function for each layer when we build our neural network architecture. And here we say enum class activation type, and inside the class we have none, ReLU, Sigmoid. And here I'm declaring a function that will return an std pair, and we say inline std pair activation function, activation function. And then we're gonna call it get activation pair, and it takes activation type. Think of a pair like a box that holds two things side by side. In our case, we're returning a pair of activation functions. The first is the activation itself, and the second is its derivative, and they take a double and return a double. This makes it easy to assign both the activation function and its derivative when we construct a layer object, which we'll do in the next video when we build our layer struct. Now we use the activation namespace to access the activation functions directly, so we don't have to write activation : every time. And here we say using namespace activation. And here we're using a switch statement on the activation type to decide which activation function pair to return. So we say switch type case activation type ReLU. We return ReLU and ReLU derivative, and case activation type sigmoid. We return sigmoid and sigmoid derivative. And then for none and default we say case activation type none and default. We return an empty pair like this. Return activation function curly brackets, activation function, curly brackets. And this means in the none case, if a layer doesn't need an activation function, like an input layer, or if we pass an invalid type by mistake, we just return an empty pair, basically saying no activation here. Alright, that's a wrap for this episode. We have laid down the foundation by defining our activation functions, their derivatives, and the enum to switch between them easily. Next time, we'll bring these pieces together inside our layer struct. If you found this helpful, make sure you like, subscribe, and hit the bell so you don't miss the next step. If you have any suggestions, feel free to drop them in the comments. Thanks for watching, and see you in the next video.